Welcome students to this video module on the topic sound plate. Students, sound plate is a device used for verifying the concept given by Fresnel, that is the concept of zones, half period zones. In the previous video module we learned about Fresnel's half period zones and the resultant intensity of light at a point on the screen. So in order to verify such a concept, a sound plate is developed. A sound plate is a specially constructed screen such that light is obstructed from every alternate zone. We learned that according to Fresnel's assumption, a wavefront can be treated as or can be divided into a large number of equal area strips called zones. So in the same way, here what we are doing is we'll divide, we'll construct a screen, a transparent screen with alternate regions darkened or making the alternate regions opaque. Okay, so a sound plate is a specially constructed screen such that light is obstructed from every alternate zone. Okay, so as I told, the main function of this one is to verify the Fresnel's half period zone concept, and also later in this discussion we can find that a zone plate actually works similar to that of a lens. Okay, let us go to that in detail after this discussion. Now let's continue with sound plate. Okay, we learned that the total intensity of light on the screen due to various zones is given by A equal to the total amplitude A equal to M1 minus M2 plus M3 minus M4, etc. That is because the light waves from alternate zones were out of phase. So that causes a reduction in the intensity, and we learned that the resultant intensity on the screen at some distance from the zones will be only equal to or will be proportional to M1 by 2. So the intensity is M1 square by 4. Amplitude is M1 by 2 only. The other contributions are negated due to their out of phase vibrations. So the resultant intensity on the screen due to all, if we consider all the sounds, that is reduced or very less. So in a sound plate, what we did is we cancel the contributions from alternate sounds. So if we allow the contribution from first zone, then the next zone contribution will be cancelled. Then the next one will be allowed. Then the next one will be cancelled. So all the out of phase contributions will be obstructed, so that light reaching at the point P on the screen will be in phase. So they will add, and the total intensity will be higher. That is the main concept behind a sound plate. Okay, now how to construct a sound plate? You can see as in the figure 1, just make or draw circles on a paper, concentric circles on a paper with a radius proportional to square root of numbers. R1 proportional to 1, R2 proportional to root of 2, R3 proportional to root of 4, R3 proportional to root of 3, and R4 proportional to root of 4. So in that way, draw concentric circles on a paper and then cover the odd numbered zones with black, or you can cover the even numbered zones also. Then take a photograph of that and develop the negative will be as in the figure 2, that act as a sound plate. Okay, so what actually we made is now known as a positive sound plate. In the reverse also you can make, that is actually called negative sound. We can see figure 4, positive sound plate and negative sound plate. Okay, so it is easy to construct a sound plate. draw concentric circles with the radius square root of natural numbers, take a photograph, develop the negative, and that will be a zone plate. Okay. Now, this is the a cross section of that zone plate. We know that M1, M1, M2, M2, M3, M3, M4, M4, M5, etc. The large number, they are the zones. And as in the case of zone plate, we obstruct alternate zones. So here you can see the first zone, the central zone is open, that is transparent. The next one, M1, M2, is the next zone, that is blocked. M2, M3 is open, M3, M4 is blocked, M4, M5 is again open. So we already learned in the previous module that OM1 is the radius of the first zone, R1 is root of B lambda, R2 is root of 2 B lambda. In a general way, Rn, the radius of nth zone, is root of n B lambda. Squaring that, Rn square equal to n B lambda, and B equal to Rn square divided by n lambda. So we know that in the case of a Fresnel half period zone, the total amplitude at the point P is M1 minus M2 plus M3 minus M4 plus M5 etc. minus Mn minus 1 plus Mn if n is odd. That is the case of Fresnel's half period zone. But in a zone plate, we know that alternate zones are obstructed. So there will not be any contribution from the second zone. There will not be any contribution from the fourth zone. So all the second, fourth, sixth, etc. contributions are cancelled or obstructed. So what will be the resultant amplitude at the point P? That is A equal to M1 plus M3 plus M5 etc. plus Mn. So only supporting contributions will be there at the point P. So the total intensity will be higher than that we learned in the case of an ordinary Fresnel's half period zone. So because here we obstructed the alternate half period zones. Okay. Now let us study in detail about the theory of zone plate. So here consider a zone plate XY. You can see a cross section of a zone plate is kept there XY, and in this case we are considering P, a source P, and the screen is kept, and Q is a point on the screen at a distance B. Okay. Now, by adjusting the position of the screen at some distance B, we'll get a clear spot of light, a bright spot at the point Q. Let that distance be B. Okay. Now we can write P M1 plus M1Q equal to PO plus OQ plus lambda by 2. That is the construction of half period zones. Fresnel is like that, because we know that the path difference of light originating from P and reaching Q through two neighboring paths differ by lambda by 2. That is why they are called half period zones. Okay. So P M1 plus M1Q is equal to PO plus OQ plus lambda by 2. Next one will be P M2 plus M2Q, that is equal to PO plus OQ plus 2 times lambda by 2. In general, PMN plus MNQ is equal to PO plus OQ plus n lambda by 2. But what is PO? PO is A, the distance from source to the zone plate. And OQ is B, distance from zone plate to the image, the screen. So it is A plus B plus n lambda by 2. That let be equation 1. Now PMN, using Pythagoras method, PMN, actually what is PMN? Let me draw this. Okay, this is the PMN. And this is MNQ. Okay, so PMN is equal to square root of PO square plus OMN square. That is equal to PO is A and OMN is RN. So A square plus RN square under root. Square root can be replaced by raised to 1 by 2. Now a can be taken out from this square root. If a square is taken out of the square root, it will be a there times 1 plus Rn by a square all raised to 1 by 2. Now you can expand this bracket and eliminating the higher order powers. Okay, because we can expand this using binomial expansion and eliminating the higher order powers, we get approximately Pmn is equal to a plus Rn square by 2a. In the same way, we can simplify Mnq is equal to b plus Rn square by 2b. So we got the expression for Pmn and Mnq. Now substitute this Pmn and Mnq in equation number 1. So equation number 1 will become what? A plus Rn square by 2a plus b plus Rn square by 2b equal to a plus b plus n lambda by 2. This one. A plus Rn square by 2a plus b plus Rn square by 2b equal to a plus b plus n lambda by 2. Cancel the a and b terms, and Rn square by 2 can be taken outside, times 1 by a plus 1 by b equal to n lambda by 2. That's equation number 4. Now we can rearrange or in a 1 by a plus 1 by b, you can make the LCM common, that become a plus b divided by ab, and take that to the other side, it will become ab by a plus b. So we get Rn, radius of the nth zone, is equal to root of ab divided by a plus b times n lambda, or Rn, the radius of nth zone, is proportional to square root of natural numbers. Okay. Now we'll go to area. How to find the area of the zone? Area of nth half period zone is area of nth half period zone A equal to pi times radius of nth half period zone square minus radius of the previous zone, that is Rn square minus Rn minus 1 square. Substituting for radius, pi times ab by a plus b n lambda minus ab by a plus b n minus 1 lambda equal to you can cancel the n lambda terms, well, so only 1 lambda term will remain there, so pi times ab by a plus b lambda. So area is independent of the n, the zone number. That means area is a constant. We have derived this in the previous session also. The area of half period zones are constant. Okay. Now let us consider the equation 4 once again. Equation number 4 is Rn square by 2 times 1 by a plus 1 by b equal to n lambda divided by 2. Rearranging, we get 1 by a plus 1 by b equal to 1 by a plus 1 by b equal to, this 2 can cancel, equation number 4, 2 cancel, Rn square can be taken to the other side. So we'll get 1 by a plus 1 by b equal to n lambda divided by Rn square. You can find a similarity of this equation with that of the lens, equation for lens 1 by u plus 1 by v equal to 1 by f, without the sign conventions and all. This is same. So when we compare these two equations, in place of 1 by f, what is obtained there? 1 by f is equal to n lambda divided by Rn square, or f, the focal length f of a zone plate, is given by Rn square divided by n lambda. Focal length of zone plate is given by Rn square by n lambda. So for a particular wavelength, the focal length of a zone plate depends on Rn and n. That is radius of nth zone and the number of zone. So you can see that what is the function of a convex lens? A convex lens focuses lens to some point. A zone plate also focuses light to a particular point. Okay, only thing is that here an advantage is that it has got multiple focal length. Depending on the wavelength, focal length is different. Depending on the number of zones, the focal length is different. Okay, so anyway, we can compare, or we can consider a zone plate similar to or similar functioning as that of a convex lens. Okay. Now let us see few similarities and differences between zone plate and convex lens. You know the equation connecting the image distance, object distance and focal length of both are similar. These two focal length depends on wavelength. So both these suffer chromatic aberration. Both these devices can be used to focus light to some points. So these are some similarities, and there are few dissimilarities also, differences also. What are they? In sound plate, image is formed by the phenomenon of diffraction, but in convex lens, the image is formed due to refraction of light. That's a basic difference between them. Sound plate has got multiple focus on either side of the plate, and therefore intensity of image formed will be slightly low. Convex lens has only one focus for one wavelength. Light is focused at one point, hence the intensity will be high. The path difference between any two alternate sound is lambda, but there the waves have, in the case of convex lens, the waves have no path difference at the point where the image is formed. It is formed by the phenomenon of refraction actually. And sound plate can be used over a wide range of wavelength, and convex lens can be used only in the visible region. These are few differences between these two. So in today's module, we learned about sound plate, theory of sound plate, and we proved that a sound plate is equivalent to a lens, and we compared a lens and sound plate. Thank you, students.